This is k-means. And x-means is based on x-mean, and the g-means is based on the k-means, and it automatically chooses the number of clustering. And this is the result from multi-dimensional scaling, the proximity matrix, MDS, ISO MDS, and the Simons mapping.
Okay.
There are negative numbers. I'm not sure if it is correct. And or we need to process them to the positive numbers.
What do you mean you don't know that's correct or not?
I mean, it should be, the result should be positive, but the calculate it get to negative.
Look, I have no idea what you're showing me. What are those numbers? And how did you get these numbers?
It is based on the data. You can see the CSV file.
Yeah.
No, look,
this data is from the CSV.
No, look, you know exactly what they are because you wrote a code or you use data, whatever. But I have no idea what you've done. So you need to explain to me what it is, what you've done, and what you expected.
Okay, how you can show the interface?
Yeah. First upload, and then you can choose what algorithm you want to implement. For example, MD Simons mapping.
Okay.
And this is the CSV submit.
Okay.
Success. And this is the result from last option action.
Okay, no. Okay. And how do you know this this result is correct or not? How do you know that's correct or not?
We following the functions here.
Did you implement or did you just use copy the code?
But I understand what it means. I copy the code, but I understand what it means.
Okay, so according to that, is this a correct answer?
It should be the correct answer.
So not happy it is minus 7.25?
Yes.
How did you get that? Isn't that from 0 to what's the range of numerical space when user had to create data? Show me the data. So it looks like it's between 0 and 8. And
yes.
How do you get the negative value?
Because multidimensional is based on the proximity matrix. it is it's based on the productivity metrics, and this is this similarity. And after calculation, it is becomes the negative values.
No, okay. Well, then how are you supposed to know the mapping to the scale between 0 and 8?
So maybe this way is not right, incorrect. So you can try the k-means.
Yes.
Yeah, this is from
k-means.
0 to 8. Maybe the summary is not incorrect here.
I think based on what the like wiki is saying, that the center mapping and the other mapping is doing, it's mapping to a different space. So they preserve the order, but then the value doesn't preserve. So it preserves the relative order of different data points. That's why the value could be negative, because it does not exist in the same space.
That's right. And do you know how to align this scale space?
I can do some process on them.
How would you do that?
The non-linear interpolation.
How would you do that? How would you remap this minus 7.25 to 7.75 to 0 to 8? How would you do that mapping?
Use the formula.
Well, okay, which formula are you going to use?
We assume this is 0 and this is 8, and then calculate the between numbers.
How?
It is not difficult to implement.
Look, even the k-means says 0.1 to 8, not 0 to 8. And
Yes.
why are you making minus 7.25 to 0?
I think he meant linear translation to map it to stretch it to 0 and 8.
Yeah, but my question is, how are you going to do that? Do you know how to do it? No, I'm not asking you, Tin. I'm asking students. And if you look at the Salmon, MDS, PCA, they all look different. They all look, it doesn't map between 0 and 8. Okay, can you go back and pick a different one? Let's see how the X means and the G means produce. Can you do that?
Yes.
Mm-hmm.
Choose first one.
Oh, wait, don't do the different one. Use all the same data.
Okay.
0 to 5, 0 to 8.
Need X means.
Oh, yeah.
Yeah.
Not yeah, that one. Okay, so this one is 0.13. Okay. Okay, so this is high. How about MDS and PCI? What MDS? Which MDS algorithm did you use?
The classical.
What is classical?
Uh,
There's no such thing as a classical MDS algorithm. Which one is it?
we use Euclidean distance matrix.
Yeah, even some of mapping uses Euclidean distance metric. Look, using the existing method is fine, but you really need to understand what's actually doing. Show me the PCA one then.
Uh,
No. Show me the result of PCI. Okay, this one is -6 to 7.54. So do you understand these numbers? Why it comes like that?
no.
Okay, so my question is, do you know each algorithm's how it's been calculating, or what's calculating?
I read the explanations, so I know how it works, but I don't know how exactly it works.
What?
Uh, uh,
Can you explain what the PCI means? What it does? What it means?
it is used.
Do you understand the physical meaning of PCI?
Yes,
What is it?
it's mapping the multidimensional data to the dimension you want. Reduce the dimension.
How? How is it doing it?
Uh,
How do you calculate PCI? How do you calculate PCI?
uh,
Anyone? Can anyone explain how to calculate the PCI? No one?
I think the PCA find some special numbers from the original data.
Okay. Okay. Then what's special number? What's so special about it?
The first should be the data has the largest difference in its SI vector in the original data, and the second.
What is, sorry, what's a
okay.
vector? What vector?
Okay, I don't know how to say that.
Look,
the vector has largest difference.
A vector, the largest difference. What kind of difference are you talking about?
How to say that?
How do you calculate the PCI?
The largest variance.
Largest variance of what? How do you calculate? Look, look, let me get this straight. This is a capstone project, right?
Yes.
Am I right?
Yes.
Yes.
Okay. You need to treat this that you are creating a product for a customer. Do you expect me to pay for this product? Whether you created something, came to the customer, showing the customer, and the customer asks a question, what is it doing? How are you calculating this? And you don't know. Do you expect me to pay for this product?
Sorry, it's our problem. Sorry, it's our problem.
No, yeah, clearly it's problem. Look, using the method is fine, tool is fine, as long as you know exactly what's doing and what you're getting, that's fine. Because you need to tell the client, we decided to use this because of certain reasons. And if you can't explain to the client why you're using it and what your tool is producing, how can your client can trust the product you created? So using PCI, summer mapping, those things is fine. You can use it, but you need to use it properly. And if you don't know what each algorithm is producing, then you cannot make an adjustment. For example, the result you're getting from PCN and MDS and summer mapping obviously is not fitting the range between 0 and 8. There is a technique to fit that in that reproject or try to limit the range in between 0 and 8. There are techniques to do that. But if you don't know what each algorithm is doing in the first place, you probably have no clue how to do that. Right? So among this, except as K-mean and G and X means, other multidimensional scaling techniques, probably among those, easiest one will be the principal component analysis. That's why I asked how what does it mean? What PCA means, how to calculate the PCI? Because that's probably the easiest thing that you can use. Have you guys learned PCA? Possibly from undergraduate study or statistics or anything like that? Did you learn PCA?
We have learned machine learning.
No, PCA is not machine learning. Multidimensional scaling is not machine learning. It's just a statistical tool. Is this the first time you heard of PCI?
Yes, in this project, we first time.
So you never heard of a PCI?
Never used it before.
Okay. Okay. So which degree are you guys doing? MIT or Master of Data Science or?
MIT, I think.
You're doing MIT?
Yeah.
All of you?
Yes.
Okay. And you never heard of a PCI before?
I have used the PCA in machine learning. before.
Yeah, the PCA is not really machine learning. That's just very fundamental statistical tool. Okay, so you don't know PCI. But do you know how to calculate a PCI?
No.
No? Okay. Okay. What should I do? Okay, you really need to understand what the PCA is. Okay, let me see. What's the best way to do this? Let me see. Okay, can you see my screen?
Yes.
Hang on, wait a minute. This has auto. Let me see. Large take option. No, I need a camera. Right. Okay. No, this is not really good. Okay. Now, well, let's talk about a two-dimensional space. Okay.
Yeah.
If you have lots of data points, okay. Okay. The principal component. Okay. I'll explain what the physical meaning of principal component. Okay. If you have data points, okay. Principal component means you try to find the smallest box, smallest rectangle to contain all the data points, but it has to be smallest square, not square, smallest rectangle. Okay. Once you find the smallest rectangle, okay, if you look at here, there's two axes, this one and this one. So basically, there's two vectors here. Okay, vector length of the one, vector length of the one. These vectors are called eigenvectors. Okay, and the length, size of this edge, these are eigenvalues. Have you heard about eigenvectors and eigenvalues?
No.
No? Okay. Are you sure? What was your undergraduate degree?
Computer science.
And you never heard about eigenvalues and eigenvectors.
Yeah,
I heard vectors, but not eigenvalues.
Yeah, okay. Right. If you have data points, okay, so you have lots of x from x is data point, okay, x from 0 to xn, okay, n data points, okay, and from this you can calculate average, right? If it's a data points like this, somewhere in the middle, center of gravity, there's an average, right? Do you understand average?
Yes.
From these data points, you can calculate average, right? And for each data point, you can calculate the difference between average and each data point. Right?
Yes.
Not yet.
All right. So you have this. So this is a variance for each data point compared to average. So this one you have it from 0 to xn minus x average. So this is one vector, right? And you can multiply this with the same thing. You can multiply these two vectors, same vectors, one in vertical, one in horizontal. And that will create covariance matrix. And for this covariance matrix, no, sorry, no. There's a vector and scalar value which satisfy this equation. And to find these vectors and the scalar value, you got to do -1, or you calculate -1 m, and this will cancel it, and multiply -1. So basically, you need to calculate the inverse matrix. So that means you got to solve this with the optimization routine, singular value decomposition or LU decomposition. Then you can find vectors and corresponding values. If it's two-dimensional data points like this one, you're going to get two pairs. Okay, you're going to get the two vectors. And you're going to get the two scalar values. So these goes in a pair, right? And largest vector one correspond to this axis. The smaller vector is this one. And principal component, usually you pick the largest one. So this is the most important component. And basically you reproject all the data points against this most significant vector or vectors if you were selecting two. So that's a principal component. So PCA basically finds this axis and reproject all the data points. And the number you are getting for the PCA is a value along this axis. And you have just -7 point something to 8. That's -7 in here. So somewhere at 0 is somewhere here, -7 here, another positive sample somewhere in here. That's what you guys got. But you need to make sure this is sitting between 0 and 8. If you know this, how it's working, then you can easily do this scaling to fit into range 0 and 8. Do you understand? Do you get some idea?
Yes.
Okay. So what you've done so far is okay. uploading the file from that file using k-mean, whatever it means, and summer mapping, PCA, those are fine. But you need to make sure that the data is actually projected onto numerical space, which is 0 and 8.
But different users has different numbers.
That's correct.
Okay.
But the users are usually asked to rate the numbers with the provided numbers. One user is not going to put the number between -3 and 400, right?
Yes.
They're all putting numbers between 0 and 8, not exactly 0. Some put the 0 point something, some put the 7 point something, but the maximum is 8, minimum is 0, right?
Yes.
Yeah.
So if you use someone mapping a PC or MDS type of stuff, you need to take care of that kind of the rescaling part. Okay. If you use a k-means and those means, then you probably don't have to do the rescaling because you're already working in the same scale
Yes.
and same domain.
And I originally want to ask you if we need to implement this rescheduling function. Yeah.
Yeah, you do, because I can't just keep it as a -7 and a 7.25.
Yeah, and we will implement it.
Yeah. Okay. Anything else?
Do we need to implement other functions, or just this one?
Which one?
The mapping algorithm. Do we need to implement the predict value, or let users to input the query?
Sorry, what kind of query are you talking about?
Collect the data from users.
If you have time, that'll be good if you can have a page where user can use it so the system can collect the data. That's what we talked about the last week.
Okay. So now we just need to change these negative values to between 1 and 8. Is that correct?
No, not 1 and 8, whatever the range, original space. Yeah.
It's just an example. Yeah.
Hmm.
Yeah, we know it.
Okay, so PCA is quite straightforward because you already have this access, but you need to do the same thing for the MDS and the summer mappings. Okay.
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 Okay, so for those techniques, you probably need to do a slightly different way of doing a remapping, because you can't just put the first one, the last one, and 0 and 8, and the linearly interpolate in the middle. You can't do that because the whole point of this is it's a non-linear mapping, so you can't just simply linearly recalculate.
Okay.
Okay.
Okay. Do you have need to implement research more mapping algorithm?
No, that's okay. Whatever you have so far is fine.
Okay. That's my question. Yeah, thank you.
Okay. All right. Anything else?
Yeah, maybe no.
Okay. All right. See you next week then.
Yes, see you.
Okay. See ya.
Thank you.
All right.
See you.
See you.